In today's world, energy storage is everywhere, in our homes, industries, and infrastructure, which makes fire safety more critical than ever. Lithium-ion cells offer high energy but are prone to fire or explosion due to their chemical-based storage. In contrast, supercapacitor cells use electrostatic energy storage, making them far safer, with no thermal runaway risk, even in extreme conditions. In this video, we'll put both technologies to the test, starting with an internal short-circuit drill test, followed by a direct flame exposure. Our goal is to show how each performs under extreme conditions and why safety should be a top priority in modern energy systems. The first test, known as the internal short-circuit drill test, simulates an internal short circuit by puncturing each cell using a metal drill. On the left-hand side, we have a supercapacitor cell, and on the right-hand side, a lithium-ion battery cell. As the drill makes contact with both cells, observe the supercapacitor on the left, it remains completely inert. Now look at the lithium cell on the right, within seconds, it reacts violently. Based on the internal short-circuit drill test, it can be concluded that supercapacitor cells are inherently safer and do not pose a fire risk. The mechanical rupture and exposure test involves physically cutting open a supercapacitor cell to observe its internal structure and behavior under extreme conditions. The goal is to verify that there is no liquid electrolyte and catches no fire or combustion occurs under extreme conditions. As you can see, cutting open the cell reveals no liquid electrolyte inside. Even under direct flame, there is no ignition or thermal runaway. The test confirms the inherent safety of the supercapacitor cell, showing no electrolyte leakage or fire risk, demonstrating its stability and integrity even when severely damaged. Supercapacitor gasoline fire test. A live supercapacitor cell was exposed to open gasoline flames and showed no ignition, no explosion, and no loss of voltage, proving its fire resistance and safety. At the beginning of this test, the multimeter shows 3.215 volts, confirming the cell is live. We place it into open gasoline flames, yet unlike lithium batteries, the Enercap supercapacitor stays stable, no fire, no reaction, no loss of charge. Even after exposure, the voltage remains unchanged, proving its superior fire resistance and reliability. This gasoline fire test proves that Enercap supercapacitors are inherently safe, maintaining stability and voltage even under extreme conditions. Next, we will conduct the direct flame exposure test to assess the fire safety performance of supercapacitor cells. A small flame appeared on the supercapacitor but was safely blown out with ease, no danger, no reaction, proving its high safety. The supercapacitor cell remained stable and safe during the test. The flame was easily blown out, with no fire propagation, no explosion, and no signs of thermal runaway, unlike lithium or other conventional batteries. This demonstrates excellent fire safety performance. Results clearly demonstrate that supercapacitor cells provide a high level of safety and reliability, even under extreme conditions. Here is the overall summary of the safety test we have conducted. As you can see, supercapacitor is way more safer than lithium cells. Emtel Energy. Discover safer, longer-lasting electrostatic energy storage solutions. Learn more at www.emtel.group.